we are going to discuss Azure and containers. Containers are the big thing in software right now. Everyone wants to do something around them, and Azure offers multiple options there. Before we begin, Amina already introduced me, but just to mention, I work as a solution architect at Authority Partners. I've been Microsoft Azure MVP, that's where Mustafa Loves Azure comes from. And I'm also very certified in different Microsoft technologies. I've been certified to everything since 2003, up to these latest cloud technologies as well. So before we began discussing the containers in Azure and why and how, first, why containers in the first place? Where did we come up with the idea for the containers and why do we actually need them? So, as someone who's been in this industry for a very long time, I cannot tell you how many times I heard this sentence, it works on my machine. We tend to do that, like if we are setting up, if we have our own environment and we like set it up in a certain way, it might work, but wherever we deploy our solution, it might not be the same environment. It might depend on multiple variables, so we might end up in trouble. Another thing is that we want every environment to look exactly the same. We always want to. It doesn't really matter if it's like dev, QA, UAT, production, whatever environment we're in, we want to ensure that every environment looks exactly the same. We also want increased velocity. That is a really good thing when we're working on these kind of solutions. And we want to be able to run our solution anywhere. One of the major things about this run anywhere is with the evolution of cloud computing in recent years, we have many different cloud providers. Microsoft Azure and AWS being the major ones in the market, but also different cloud providers like Google has its own cloud. Every major IT company like Oracle, IBM, they offer their option for the cloud as well. And there was a lot of concerns around it, like if I set up my solution to run in a certain cloud, am I locked in? What is going to happen if I don't like the prices or terms or whatever in that certain cloud? Do I need to develop my solution from scratch? Do I need to start over and so on? Basically, containers are the solution for that. It basically bypasses the vendor lock-in. We kind of have option to move our containers anywhere. This is like this run anywhere is stand for. So what does this run anywhere means? Like it can run on Linux, it can run basically on Windows as well. It can run on any cloud. It doesn't really matter which cloud provider we choose, container should run anywhere. And finally, and this is a big thing in the recent times, it's also like good with the IoT. We can run containers on multiple devices like Raspberry Pis, drones, or whatever industry devices we're using. They are suitable for deploying containers as well. So we had virtual machines in IT industry for over 20 years now. Virtual machines became a standard, an easy way to deploy new environments and set them up. And when containers started evolving and started to become a thing, there was a lot of pros and cons, and people that were used to virtual machines were not really convinced that it's the best way to go. Like when we said like containers are easy to deploy, they are easy to transfer, we can easily set them up. Same pros were given for virtual machines, like, yeah, but I can like deploy my virtual machine from template, I can copy it easily and so on. But it's not really the same thing. And why? Well, virtual machines and virtualization in general and containers rely on certain things that are the same. Like we are going to have same infrastructure, we are going to have same host operating system in both cases. But this is where all similarities end. Basically, On virtual machines, we're going to install hypervisor on our host operating system, and then we are going to set up virtual machines. And what happens here is that each virtual machine has its own operating systems, it has own bins and libraries, its own application, and they are completely isolated from one another. Like everything that we are using for this virtual machine is belonging exclusively to that virtual machine. It's going to have its own files for everything. Now, with containers, we have a lot of shared things. Like with the container runtime, we are trying to share components that are same across the different environments. So we're still going to have some unique applications and libraries for certain applications, for certain containers, but we are going to try to share everything that is below. So how does this look like? So for example, let's say that we are setting up virtual machine, that we are setting up container for Windows Server Core. So first layer is going to be a Windows Server Core. That is going to be a shared component. So if you have multiple containers that are going to run Windows Server Core, no matter what the configuration afterwards is going to be, every container is going to share Windows Server Core files. Now, the next step, if we require IIS for our application, this is going to be a next layer. And on this layer, like every container that requires IIS to run is going to use components from that layer as well. And so on. So the story continues until we reach the unique layer, like something that is unique for our application. It could be a library, or it can be like shared setup, like all our application might run on same settings, but we are going to deploy that little special part. Now, what this brings us is a lightweight. It's allowing us to be very mobile. It allows us a certain amount of speed that we couldn't do with a virtual machine. Because if I wanted to deploy new version of my application on a new instance of virtual machine, sure, I can copy a lot of things, but it will require to copy complete virtual machine along with everything that is needed for that virtual machine. So I'm going to copy all Windows Server operating system files, all specific roles and feature files that are required, all libraries, options, settings that I need for that specific application, and of course, the application itself. With the container, I don't need to do everything. I need only to deploy what is unique. So everything below is shared between my containers, but only unique part is isolated and needs to be deployed. So this is giving us a much smaller footprint that is required for our application to run and to deploy, in fact. So one component that is very important in this story and how we are going to build it and deploy is container registry. So what is the container registry in the first place? So basically, this is a repository for storing container images. If we go back to the previous slide, basically all of our layers we can set up as a container images. So basically, we can have everything ready and prepared. Now, in container registry, we are going to have all these images ready and in place. And once we want to deploy application, we just call for the containers that are required for our application. And this allows us to quickly deploy new versions, especially because how this deployment works is it checks for the components that are changing. So basically, for the first deployment, for the initial deployment, if you're setting up new environment, new host completely, it will take a little bit more time because it needs to collect all the layers. Now, after the initial deployment is done, we can easily and quickly deploy only the parts that are changing. So basically, we are not deploying all the layers every time. We are just deploying what is changed. There are multiple public registries as well. Docker Hub is a great repository for. It's basically Docker Hub is a GitHub for containers. It offers multiple, like millions of different images from different providers that we can use for our solutions. We can also set up private registries that can allow us efficient and secure storage, especially when we want to isolate our solution. We probably, like, same thing with GitHub. It's great for sharing things and everything, but we want private part for the application that we develop for a living, because we don't want to share our code with anyone. So maybe let's show how this is set up. Let's create a container registry. Okay, so we're selecting container registry. What I need to provide is a subscription. I'm going to create a new resource group for this. Let's call it Dev Talks. I need to provide names, so let's try Dev Talks. Is it taken? No, it's not. Interesting. Okay, for the location, I'm going to use West Europe, only to be a little bit closer to me, so I don't have to wait for the deployments too much. I have options to select certain SKU. I'm just going to leave it as standard. Basically, it's a performance thing. And another thing, like networking, like private networking and encryption, is only available if we select premium SKU. So I'm just going to leave default networking because I cannot change it on the standard level. Same thing for encryption. I don't need really tags. I'm just going to like deploy it. And this should be done relatively quickly, hopefully. Okay, this is quick. This is faster than I expected. Okay, so we have our container registry. We can see our login server, different options. We have access keys, encryption. As I said, encryption is only managed on the premium tier. We can set up identity. So basically, this can allow us to manage and allow our container registry access from certain applications. Networking is again thing with premium tier. Security allows us to connect it to Azure Security Center, so we can scan our images and ensure there are no vulnerabilities and so on. Especially interesting part are the services. Here we can see repositories. So basically, we can see our images in here. Unfortunately, but not unfortunately, this was just deployed, so we don't see anything yet. But we will a bit later when I do a couple of deployment demos. We can also set up webhooks. We can replicate our container registry if we need. Highly available solution. We can set up replication so it can be distributed to the different regions and so on. We can also see the tasks that are running, agent pools, and so on. Right now, as I said, this is just deployed freshly, and we don't have anything. It's completely empty. Okay, another thing. If you're using like different solutions, it depends if you might or not need admin user, but if you're using app service, and we'll come to that in a bit, what is really important in the container registry, you have to enable admin user. If you don't do that, if you don't enable admin user, basically your app service will not be able to pull images from Azure Container Registry. So this is just for that specific solution, but I'm going to enable it because I'm going to need it in a bit. Okay, let me go back and let me share the presentation again. I'm going to create share. Okay, so as I said, we have multiple options when it comes to containers in Azure. Azure supported containers for a very long time. And we have different solutions. They evolved over time. We have seen many different things and options in there. So let's go one by one and see what is a choice in certain situations and so on. So the oldest option for containers in Azure is Service Fabric. Service Fabric is really cool because it supports both Windows and Linux containers. It supports stateless and stateful microservices. It can be deployed basically anywhere. It can be deployed on Azure Stack, which is basically on-prem version of Azure. And it can be done on-prem. So you can basically deploy it on your own servers. You don't need anything. You can deploy Service Fabric basically anywhere. As I mentioned, this is the oldest solution Azure supports. And what is not widely known is that Service Fabric is a backend for many Azure services themselves. Like Azure SQL databases that many people use uses Service Fabric at its core. So it utilizes the power of Service Fabric to allow you to use that kind of service. So it's really cool. It's really flexible. It offers a lot of good things. And in my opinion, the only thing that was stopping Service Fabric to evolve even more, it was limited support for programming languages. So Service Fabric, as it is, supports .NET, of course, and supports Java. But all the other programming languages, and there are many, many more, were not supported directly. For some of them, there were kind of workarounds, different options on how we can actually like set them up, but it wasn't like fully supported. And if things go wrong and you contacted the Microsoft support, you were on your own. So the lack of support for different things, more programming languages, is what stopped this service to become more popular. But the fact itself that it's used to run many of the Azure services themselves, that Microsoft is using it to deploy their own services, tells, I think, enough about this service. Next option that we got in Azure were Azure container instances. Though they were like easy to deploy and to run containers. They were really simple to use. They were fairly priced, and it didn't cost too much to run containers on Azure container instances, but there were several minuses. First one was that didn't have like orchestrator. It wasn't like fully managed service, and that was an issue for many people. And if you wanted to have some kind of orchestrator or something to manage your containers automatically, to scale out and so on, you needed to deploy something on top of it. So basically you could run your own Kubernetes on top of that, or you can set up different orchestrating services that some of them were available on open source, but it wasn't built in. It wasn't out of the box, and it required additional challenge, like effort to actually set up and deploy. At the end, what really killed the service off was lack of interest from Microsoft. They still offer the Azure container instances. You can still deploy them, but any future development is basically halted. We haven't seen anything happening in Azure container instances for, I think, 2 years now. Since Microsoft started looking into Kubernetes and allowing that service in their cloud, it basically killed the service off. Again, the main issue with the service itself was that it didn't have management options, and you had to build those additionally on top of the solution itself. Okay, Azure App Service. This is one of my favorite Azure services ever. It's been there from very beginning, since we started using our model for Azure. Azure App Service became available, and it's basically one of the oldest services and one of the most reliable services. Phenomenal way to run your website, and I was really excited to see that container instances are part of the Azure App Service. They've been for some time now, well, I think over 2 years, and they are really cool and easy option to use if you don't have complex infrastructure. They are quickly to build, to deploy. You have built-in scalability for these. Now, since recently, they started supporting Windows Server containers as well. So that's a really cool thing. At the beginning, when containers were announced on Azure App Service, they only supported Linux. Now they support both, so both Windows and Linux. And they are really easy to use. The issue with them is that basically, again, you don't have an orchestrator, and they are really good for some of like easy scenarios. When you have a simple app, not many APIs, not many containers on their own, it's really easy to set up and use. So let's quickly deploy that one as well. Okay, so let's deploy a web app. So I'm deploying web app. One I need again is, what was the name of the group? Dev Talks. Okay, I'm going to use same resource group. Let's see Dev Talks for the website. Is it available? Of course it's not. 01. That one is. Okay, so during this setup, I can select either code, which will require me to push code to my app, or I can select containers. Okay, so I'm going to select containers. I'm going to select Linux, but both Linux and Windows work. For the location, again, West Europe, just to be a little bit closer to me. I'm just going to leave the plan as it is. I don't really care. I'm going to delete this afterwards. Really cool thing is that I can connect it to my container registry as well. So I can set up the container registry here, select if I had in my container registry, which was just created, if I had prepared images and everything, I could just like set this up and pull the images from there. And it would like continue pulling. Whenever I publish new version of my container, it would automatically deploy it here as well. So, but I don't have anything there. It's completely empty. So I'm just going to skip this. I'm going to go with the default option. For the monitoring, we don't have much because the container instances don't support application insights. Tags I don't have, review and create. And start deploying. This deployment is not as fast as container registry, but is usually fairly fast. Okay, so web server farm is done. It should. Let's see, there's a message somewhere. I'll send that. Okay, here we are. It's done. So I have my container up and ready. If I go to URL, it will give me the default website look, blah, blah, blah. Nothing special in there. What I have is I have container settings here. I can like look at the different options, see what's going on with my logs. We can see that it pulled off some container image, some default container image, and deployed it to my site. This is basically just like HTML to offer like default site. I mentioned that we have automatic scaling. So what can we do? Like we can do the scale out, and we can set up the custom auto scale based on different metrics. And I can do like, let's say I add a rule and I say if my CPU on average is greater than 70% for more than 5 minutes, add another instance of my application. How many instances I want. So minimum is 1, maximum it can be like, I don't know, 3, and default is 1. So whenever my CPU reaches 70% and it's there like longer than 5 minutes, another instance of my application will be done, another container will be added, and everything is running fine. Like performance will go back to basic defaults, it will drop below 70% and so on. Now, a very important part that I always like to tell people, once you create scale out rules, you have to create scale in rules, because what will happen in this case? My CPU goes over 70%, it will add an instance. It goes over 70%, it will give me another instance. And I'm at 3 instances now, and I'm running 3 instances, and my CPU drops below 20%, I'm still running 3 instances. I need to do a scale out rule. So scale based on metrics. If I add here that my CPU percentage is less than, let's say, 50%, then for more than, I don't know, 5 minutes, then drop. And this will drop my oh, sorry, I didn't go through it. What I need to do is still do an action. I need to set up decrease count by 1. And this will go to my, this will remove the instances that I no longer need. So basically, once I have increase in workloads, it will add instances. Once I my workloads decrease, it will remove instances from there as well. All I have to do is save, and my scale out is set up. So basically, I'm safe to know that my application can handle like triple the load than what is the default. Of course, I can change those rules and increase maximum to much higher number, so it can accommodate very, very high workloads. Okay, let's go to the presentation. Thing is Kubernetes and Azure. Now, this is the part where it got interesting, because Microsoft basically, when they decided to go with Kubernetes, they dropped almost everything else. Azure container instances will completely killed off. Nothing is done on their development. Azure App Service has some small tweaks now and then, but nothing major as well. All forces when it comes to containers are directed to Kubernetes in Azure. So basically, this is the thing that you want to look into if you have a real need for containers. Azure Kubernetes Service offers really great things. So it's fully managed Kubernetes service. It has everything built in. It's orchestrator, DNS servers, service discovery, everything is already in there. It allows elastic provisioning, so we can scale out, scale in whatever we want. It has fast end-to-end development, and it can be managed. Identity and access can be managed with Active Directory, Azure Active Directory, which is really cool thing because it helps us to maintain access over resources. What happens when you, like, for a lot of resources, when Azure Active Directory is not in play, what happens is that for each service, we are deploying new username and password, setting up new admin access, and so on. So it's perfectly fine when we have 1, 2, 3 instances, clusters. But what happens when we go to dozens or hundreds or thousands even? It becomes a real problem. So having management over identity and access is a really cool thing. Orchestration for AKS is across 29 regions. It's still not available in every data center. This is a thing about, like, Azure data center deployments. There are over 60 of them now, but all of them don't get all the services at the same time. Like for the new services, they are deployed in the core data centers. So they are like core data centers that were there from very beginning. For Europe, it's North and West Europe. For US, it was East US, West US, and South Central, and so on. So these are the core data centers, and new services are always available in those data centers first. Then they are distributed to other data centers as well. And in time, all of them get the services. But the latest, like the brand new data centers, don't get everything right away. So It's available in most of the data centers. It's supported on Azure Stack, also IoT right now. It has all the elements of orchestration. We can set up scheduling, affinity, anti-affinity. We have built-in health monitoring. We can monitor our services and know what's going on. Built-in failover, because by default it creates a cluster of 3, basically minimum for a cluster, and it has a failover nodes and auto replicates, auto heals everything. We have built-in scaling. Networking is also managed by the Kubernetes itself. Service discovery was built in. I already mentioned that. And we have coordinated app upgrade. I will show that in a bit as well. So let's start with the Kubernetes and services. And this is basically going to be the end of the slides in general. We're going to stay in portals right now until the very end. So the Kubernetes as well. So if I go to Kubernetes service, we're going to deploy that one as well. So the resource groups was Dev Talks. Kubernetes, let's call it, well, Dev Talks, why not? Something else, right? Dev Talks, okay. West Europe, that's good. Availability zone, I'm going to leave that. We have different Kubernetes versions. I'm going to leave it a default at this time. Node size, what is going to be my node size? Node count, like the default node count that I have. Let's see. We have like node pools. I have one pool with 3 nodes. I can add additional pools if needed. I don't need it for a demo, but I could. We can set up authentication. We can use pre-built server, like pre-created service principal, or we can set up with the system sign managed identity. We can enable role-based access controls for this one. Also, AKS manage Azure Active Directory. If I wanted to, I could set it up. I'm not going to do that at this time. Also for the encryption, we can, like, everything in Azure is encrypted with Microsoft managed keys, but we can use our own keys as well. So I'm going to leave it at the default settings. For the networking, I can use either Kubernetes network configuration or Azure container instances. DNS prefix name, I can customize it if needed. Also traffic routing, security, different options. I'm just going to leave those at the default. What I could do is, same way as I mentioned with Azure App Service, when I deploy containers through the web apps, I can select container registry. I could do the same thing here. Again, my container registry is completely empty. It doesn't have anything in there right now. So I'm just going to leave that at the default. I'm going to say nothing. I have options for Azure monitoring enabled by the default, sending my logs to log analytics. I can enforce certain Azure policies if needed, like what can be done with clusters, what cluster size it's allowed, how many nodes, and so on. It can be managed through Azure policies if set by IT. For the tags, I'm going to leave it, and let's create. Now, this is probably going to take a little bit more. It will take a little bit more time to actually deploy the Kubernetes cluster itself. But while we are, I'm going to show you in a little bit why it's going to take a little bit more to deploy. So in the meantime, let's switch to Azure DevOps. I have a very, very, very simple application there. So basically, this is Node.js, nothing special. It's just Hello World. I'm using Hello World because I don't want to spend too much time deploying and waiting for my deployments to finish. I want this to be as simple as possible. So I want to set up deployment to different container options and see how they work. So while this is going on, let's go to our resource group and let's look at our app service. So app service, in app service, I could certainly go to my pipeline, set up, like create pipeline, do everything manually, but let's skip that. Let's do automatic deployment. Let Azure do this for me. I don't want to waste time on that. So in my deployment center, let's get started. I select a repository. So my code is in Azure repos. I'm going to select Azure repos. Okay. In my organization, I'm going to do project Dev Talks. I have Node demo repository, only one main branch, nothing there. I'm going to use that. So I already have a Docker file. Let's go to the repo. So I already have a Docker file in there. So it will automatically read my Docker file and see like what is required. I'm going to say, okay. It's gonna ask me for container registry. So it automatically detects that I have a Dev Talks container registry in this resource group, and it offers me to use existing. I could, of course, create a new one, but I'm gonna use the existing one. And I'm gonna run this. Okay, cool. This will, sorry, this will actually take a couple of minutes. In the meantime, what's going on with my, okay, the containers are still running as well. Let's see what goes with the pipeline. Did this create anything yet? Not yet. Okay, we're still waiting for some of the deployments to finish. Any questions while we're waiting? Okay, it started. So the deployment started. Let's see. Okay, so it created my pipeline, one of them at least. So this one, let's see what's in there. This one automatically created. It's building a Docker image and pushing it to container registry. So basically, it created a task to build and push an image to my container registry. Okay, let's see if the task will succeed. So it's running. It's building an image. Again, this is a reason why I wanted to use Hello World application, just to have it like in a really simple, really fast to build, goes in 32 seconds. Okay. Pushing an image. This should finish soon. So in the meantime, let's go to my container registry and see in the repositories, nothing yet. It didn't finish yet. Okay, so here it is, finishing pipelines. Okay, so this one finished. If I go to refresh, here it is. My repository, my image is done. It's created, it's deployed to my container registry. Okay, this will automatically trigger the second task. So let's see what's in there. It's running. Okay, fine. I know it's running. Let's see what's in the task itself. So this one, it basically sets container registry secrets, uses Azure CLI to collect the information needed, and then it's deploying the service to Azure Web App. So now the part when I said in the container registry that I need to enable admin access. I need to enable admin user. This is the part that is required. So this part, collecting secret and information for the deployment, is required because did this finish in the meantime? Let's see. So in the release, It's still running. Okay, so it set up the secret. It's running on a web app on container deploy. It should finish relatively fast. Okay, while this is running, what I wanted to show you in back to the resource group in this one. So if I go to the container settings, here are the information required for my container to collect information for container registry. So basically, it can pull the image from there and use it during run. So basically. I needed to enable this admin user so this information could be passed to Azure Web App and it can pull the secret out of it. Okay, so this one was done. Now, what we can see in the logs here, it's collecting the files. So we can see that it's downloading a bunch of things. So it's downloading this time 40 megabytes of something, then one of the 491 bytes, so on, so multiple. Okay, so what is the status? Pulling something again, pulling 204 megabytes. These are basically all those layers that we have. And during the initial deployment, because nothing is present by the default, I didn't like, when I deployed the web app, it's completely empty, just one HTML file having a placeholder, so I know that site is up. But now, once I started the deployment, it's collecting all the layers for the first time. Now, this will not happen during the next run, because during the next run, it will only deploy files that are changed. It will not collect everything every time. Okay, so this one's done. App service is still downloading, and let's not wait for it. Let's look at it in a bit. Let's do the same thing for the Kubernetes service. Did the Kubernetes service finish? Oh yeah, it did. Okay, so in the Kubernetes service, we have a little bit a different situation. We have more complex environments. We have different namespaces that we can use for different environments, different settings. We can see the workloads that are currently running. What we have currently is basically just the core Kubernetes services. DNS, autoscaler, metric server, agent. So basically something that is used internally for Kubernetes. This is the part of the managed service that it's running things for you. We can also see the services and ingress that are running. Everything is currently just basically core Kubernetes services running on private IPs. We can see storage settings. We can see the configuration, what is the current setup. Node pools at any time. We can add more, or we can add it. We can scale out to more nodes on this specific pool. We have a cluster configuration that we can manage. We can see the current version. We can upgrade it at any time. Again, scaling options, networking, dev spaces that are really convenient for the development and so on. But let's see the same thing, like if I wanted to deploy, I could do it right from here. So let's do the same thing we did for the app service. I'm going to do this one. I'm going to select Dev Talks again, Node.js, main, next. It recognizes my Docker file. I select, okay, let's do the Dev Talks. Let's call it Dev. Let's call Talks Dev as a namespace. I will use the same container registry. Done. Deploy. Okay. In the meantime, let's see what's going on with my container on the web app. Did it manage to get everything? No, container settings. So it's, where are we? Okay, so it's ready. So if I refresh this, here we are. Hello world, all done and ready. Now again, this is taking a lot of time because for the first time when we are doing deployments, it grabs everything. It needs all the packages that are underlying, everything that is required from the Linux OS to specific Apache role and so on. So basically everything that is required for my web application to run, it will be pulled for the first time. If I do a change on my code and do a rerun, the change will be fetched really fast because it's just comparing the files that are affected by change and deploying them next time. Okay. So what's going on with this? Okay, so already created something. Let's see if I have a new pipeline. So I have one. What I want to show you here is basically the new one that was, oh, come on. The new one that was created for the Kubernetes. If I look at the edit, I can see exactly the same steps. Build an image, push an image. Exactly the same thing. So basically, in both processes, like when I did a build of my container, the first step was same. It doesn't really matter if it's app service or Kubernetes or container instances or what else did we do? Service fabric. It doesn't really matter. It's always going to be a building a container. Container is always going to be exactly the same. So this is the part where it's like multi-cloud, any device. Container is always going to be the same, no matter where we actually deploy it. So that is a really cool thing about this. Okay, so let's see. This one is still running. It should be done like in a minute or something. Okay, so it's already done. It's just doing the post checkout. So let's see in the research group, if you go to containers and repositories, we can see now two different repositories. One was deployed for while we were building for web app, second one for Kubernetes. Okay, so this one, why is it so? Okay, here why pipelines in your region may be impacted by live sites. Okay, perfect. The best thing you want to see when you're running a demo. Okay, it actually finished, but it didn't update. Okay, so this should start a second release. Let's see what's created in that release. So in this release, we have few more tasks. We have Kubernetes set image secret. We are generating Kubernetes manifest file and then deploying Kubernetes manifest. So these are basically three tasks we have. Two are like kubectl, and one of them is a PowerShell script that is just generating manifests. Okay, this fine. Let's see where are we with this task. So it's running. Generate done. Secret collected, manifest done. Is doing a deployment. Okay, why are we waiting on this? I'm going to do two things on these tasks because when it automatically does this, it creates triggers, automatical triggers. So every time there's a code change, it deploys it. So okay, save it, and I'm going to do the same thing for the second pipeline because I'm going to create a new one, and this one can trigger. Did I click save on the first one? I hope I did. Let's see. Let's double check. Yeah. Okay, all done. Let's see where are we with the release. So that one is done. So it's completed. Let's see where are we. So on the service, on the workload, let's see. We can see that our namespace is created. It has two pods running right now. So really cool. Everything is ready. If you go to service and ingress, we can see that this node was assigned with the external IP addresses. If you go to this one, Come on, come on, come on. Don't let me down now. Oh, I know why this is. I'm running it on 8080. So, okay, here we are. Hello world. All good. It's running. Okay, so this is all cool. This is all good. But let's do something else. We really want to set up using YAML pipelines. All these stars that we created, and they are basically auto-generated for us. We don't have to really sweat about them. But if they are changed, if there is a configuration change, it's really hard to keep track of what is done, who done it, and so on. With YAML pipelines, we are basically treating our pipelines as a code, and we can track changes, anything that happens to our pipelines, to our environment, the same way we know what happened to the code. We have like Git history, we can see everything. So let's set up that kind of pipeline. And really cool part about it is, if at least for the simple applications, it can be auto-generated for you as well. So I'm going to set up Azure Git. I'm going to say this one, no demo. And I say I want to deploy to Azure Kubernetes service. So this one will ask me for certain things like where do I want to deploy, what are my resources, and so on. But it will offer me a subscription. So I'm going to select my subscription. I need to authenticate. Okay, let's do this one. So. Okay, so it recognized that I have a cluster. I want to use new names, dev space. Sorry, namespace. Let's call it Dev Talk. Oh, come on. My bad. Okay, Dev Talks, new one. Dev Talks. Container registry, same one. Image name, okay. Service port, all good. Validate and continue. So this will generate the YAML file for me for the first run. So here it is. It has variables for the container registry service connection. First stage to build. Then it works on the deploy. It creates manifest, secrets, deployment. Everything is there. Okay, so I could go into details, but let's go on the trust and say this will work. It's really simple app, so it's a slim chance that something will not go according to plan. If I go to save and run, it will also tell me that will create additional files in my repo. So it will commit 3 new files to my repository. It will create Azure Pipelines YAML, manifest deployment, and manifest service. So I'm fine. I'm going to commit it to the main branch and basically let it run. This is why I disabled continuous integration on those other 2 pipelines, because I knew that if I committed this, it will like create a new deployments on that one. So I would have 3 pipelines running at the same time. So if I go to the repo, I can see that my new file was just created. And same thing for the manifest. So it created a manifest for me just now, and it created a pipeline YAML as well. So basically, deployment service in Azure pipelines are now treated as a code. Previously, if I went to in the release for the Kubernetes, what I had was creating this manifest, and this was the script. It was like treated as a part of the pipeline, not part of the code. So I really want to avoid this and have these things like manifest definitions and things defined in my code rather than having them in the pipeline itself. So let's see what happens to our pipeline. So it has 2 deployments. One is build, second is on stage. Let's see, it's building an image. Okay, build is done. We can probably see it in, if we go to container registry and go to the repositories. No demo. So here it is. This was just like created right now as we are talking about it. Deploy started, downloading artifact, nothing to download. Okay, creating new pool, deploy, go, go, go. And it's done. Okay, cool. So my blind trust paid off and my YAML was generated correctly for the first time. Let's see the Kubernetes service. If I go to service and ingress, because I created brand new namespace, Dev Talks, and new service name, no demo. I can see it's running on this one. Okay. Okay, I should have like, okay, let's just let it load and I'll add a port number afterwards. Why? Okay. So 80. Come on. Is this correct type address? Yes. For some reason, let's see what's going on with the services. Okay, that's fine. Let's see workloads. No demo is running. Okay, one instance. Okay, here it is. Hello world. So this one is ready. Now let's quickly go back, go to the repo. Let's do another run on it. Let's say I want to change something. I'm going to add it. Now never do this on the main branch, never. But let's say I'll do it for the sake of the demo and bypass pull requests and everything else. But really don't do this on live, on real code, on real repository. Okay, so we did the update. Let's do the deployment. Let's see how it goes. I mentioned like for the build and everything for the deployments, that deployment after the initial one is really faster. The same thing doesn't go for build. Build will last whatever it was. So basically that time doesn't change a lot. Only the deployment times are changing for the future because depending on the changes, it will be minimal. And you don't like change a lot of container stuff all the time, and only the packages that are actually changed are going to be redeployed. Okay, build's done, publishing. Okay, go, deployment. Okay, deployment started. And we are done. So if I go back to my Kubernetes, I can see like the workloads. Let's see what's going on in here. And you can see that this was just like redeployed 90 seconds ago, something changed. So if I do refresh, here we are, change is done. Hello, Dev Talks. This is like this momentary change is in a few seconds, because what was changed, nothing much, and it selected only the packages that they have changed and deployed them. Thank you for your time. I hope you found the topic interesting and helpful. I hope this will help you down the road, that you will be able to use it. I wish you really exciting projects using containers, using latest technologies. Once again, thank you for your time, and hope to see you soon, maybe even in person soon enough. Thank you, everyone. Have a good day.